We're using physics and mathematics to help build the chair, to inspire the design and also the lamp, and getting assistance from the art teacher to make objects that were aesthetically pleasing.
If you say make a bentwood chair, make a lamp, and a book about the bentwood chair and the lamp, it's pretty simple. And I got back all these complex ideas. We showed them some different ideas of chairs, and we showed them our prototype, because you always have to do the project yourself first. And then we took them to IKEA and we gave them a checklist. We said, find something in here that looks like it would be impossible to make. Find something in here that you don't understand how it was made. Find something in here that looks like it would be cheaper to buy than to actually make yourself. They went through processes. They had to do hand-in deliverables the same way that we planned our chair using Google SketchUp.
By the time they got to the half-scale model, though, that was really getting very, very close to what the final version was going to look like. So by that time, we'd thought very deeply about, well, now you've got your basic idea, for the rough idea of what your chair would look like. What is the mathematics that you want to show through the actual design?
They made the miniature of what they were planning on making, and some of the kids made good ones, and some of them made them and said, this isn't going to work out, let's do something different.
Every sort of simple piece of mathematics they had to really think about and use. They kind of do a worksheet on it, and they show that they can kind of answer questions 1 through 36, and they can do them faster than anyone else. But give them a piece of wood and say, right, you've got one chance to cut this piece exactly right. It's got to make a mitered corner like this. What are the 2 angles that you cut these 2 pieces at?
Doing projects like Get Bent get you ready for real, like what a real job's like. You have to finish your work. You have to plan something and execute it and finish it to a high degree of quality. That's what the real world's like. Everybody has to get it done. There's no room for C workers. They had to keep getting it done. And if they couldn't do it themselves, they had to find somebody that could get it, that could help them get it done. And the reason you do the project is so that people have an authentic connection into reality. And they don't ask why they're doing it. They're doing it because they understand. Do the thing that's going to give them authentic interest instead of torturing them and then bringing the fun thing in. Let them eat dessert first. Have them learn about something fun, and then they would say, "Well, how does that work?" And you say, "Well, I'm glad you asked me that." And then you show them.
I think if you think mathematically, then then some of those things make a little bit more sense. The trig starts to fall into place when you say, oh, so actually that's what sine or the cosine or even the tangent, maybe more so the tangent in building than anything else is used for.